All right, so we are talking about radicals today. Those are square roots, cube roots, fourth roots, all that good stuff. We're going to stick specifically to square roots in here. When you get to Algebra 2 next year, you'll get to different roots besides square roots. But what we want to first do is talk about what each part of a radical is called, because when I refer to it by name, you need to know what part I'm talking about, okay? So first of all, if you'll see in that little circle, there is an N, okay? There's not always going to be a circle around it, but there will be a number there. And that number is called your index. Okay, that number tells me what root I'm taking. If it is a square root, I'm taking the square root. Let me try now. Does everybody understand what a square root is or a perfect square? A perfect square is the result of multiplying a number by itself, correct? So if it is a 2, which 2s are not normally written, which we'll talk about in a second, it's going to be a square root. If it's a 3, it's a cube root. That would be a number that is a result of multiplying a number 3 times by itself. The actual symbol, like the little line thing with the V on it, that is called your radical symbol. That's why we call them radicals, okay? And then that A, again, is in a circle. It won't always be in a circle. It will just be a number. But that number that is under your radical sign is called your radicand. Okay, radicand. So when I talk about radicand, I'm talking about the number under the radical symbol. Okay, and then right under that it says if there is no index, meaning if I write just this symbol and I don't put a number here, okay, I'll put that, okay. If there is no number there, it is understood that it is a 2. Just like when I write the variable x, what is the exponent that's understood that's there? We just don't write it. A 1, okay. So very similar to a square root. We don't usually write the 2. But if it is not there, then that index is a 2. So if there is no index, it is assumed that it is a square root. I didn't put 2 blanks there, sorry. If there is no number there, it is a square root. If I wanted to find a different root, like if I wanted to find a cube root, I would put a 3 there. Or if I wanted to find a fourth root, I would put a 4 there. Does that make sense? Now, we're going to make a list of perfect squares. It says 12. We're going to make a list of 15. So you can just put it like off to the side of your paper in your margins. Okay, we're going to list the first 15 perfect squares off to the sides. Everybody ready? Okay, what's 1 times 1? 1. Okay, so here are my squares. I'm just going to make a list. I will give you a list to use when you take your quizzes and your tests in this section, okay? I'll put the list up on the board. But we need to write it down so that you have it when we're working through these problems. So you said 1 times 1 is what? 1. Okay, so that's my first perfect square. We don't generally use 1 because dividing something by 1 doesn't change it, right? What's 2 times 2? 4. So my next perfect square is 4. And we're going to continue on. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 9 times 9. 10 times 10. 11 times 11. 12 times 12. 144. 13 times 13. 169. Yep. 14 times 14. 196. And 15 times 15. 225. Okay. So those are your first 15 perfect squares. Now, you could continue and make your list longer by doing 16 times 16, 17 times 17, 18 times 18, so on and so forth. Okay, but we're going to have a list of the first 15. Okay, and we're going to use those to help us simplify. So if I were you, I would make sure I have that list written over to the side somewhere. Those are your first 15 perfect squares. And when we are simplifying square roots, right there under where it says if there is no index of before the 12 perfect squares, it says if a radical has more than one root, the radical sign indicates the principal or the positive square root. So when we simplify these, they're always going to be positive square roots, okay, not negatives. We're not solving for x. We are just simplifying a square root. So sometimes we have perfect squares, and we simplify them, and they are turning out to be a whole number. Okay? You need to be familiar with these numbers because if you know them, it takes less time to work through them. We're going to simplify some perfect squares. That first one says we're going to simplify the square root of what? 16. If you don't know it off of the top of your head, then what you're going to do in your calculator is you're going to hit second. You're going to hit x squared so that your square root key shows up in the calculator. And you're going to put in 16 and hit equals. Second, x squared. And what is the square root of 16? That is one of my perfect squares. It is 4. So this is just going to simplify to be 4. No. Once you take the square root, it is done. You take it one time, and then you're done. Because 2 times 2 doesn't give me 16. I'm going to talk that way just a second.
You got an arrow, just like an arrow.
No.
No.
You're going to hit second, and then you're going to hit the key that says x squared on it. And then if you look in the screen, do you see how that radical symbol shows up in the screen? Okay, and then you put the number 16. Okay? Now, here's the thing, and this happens a lot. 16, when I simplify it, it turns into 4, right? Take the square root of it. Some people think, well, 4 is also a perfect square, so I should simplify again. That is not the case. You're taking the square root one time. If the result is a perfect square, it will stay that number. We're not going to do it twice. And once you take the square root once, you're done. Does that make sense? So this would not simplify to be 2 because 2 times 2 does not equal 16. Is everybody okay with that? Right. Now, what's different about number 2? I have a number in front of it. What that means is that just means it is 2 times the square root of 121. Now, again, we should be familiar, especially because we just made a list of our first 15 perfect squares. However, if you're not, what I want you to do on your calculator is hit second, x squared again, and then put in 121. I'm not worried about the 2 in the front right now. I'm just worried about that square root of 121. What is it? 11. So what we're going to do, we're going to keep that 2, but the square root of 121 turns to 11. So hit second, x squared, and then 121 equals. Okay. And what is 2 times 11? 22. And so my final answer there would be 22. All right, go ahead and try 3 and 4. Talking about going ahead and putting the 2 in there. Okay, go ahead and do both 3 and 4. We are dealing with perfect squares at this moment, so we should not be getting any decimals in our calculator. And remember, the number in front of it is that number times whatever the square root is under that radical sign. So it's going to be 6. What is the square root of 289? 17? And then what is 6 times 17? 102? Can't get my pen right. Is everybody okay with that? And then the same thing for 4. That is going to be 3 times the square root of 400. Okay, so 3 times, what is the square root of 400? 20. And then 3 times 20 is going to be 60. Okay, so sometimes we have perfect squares that will result in a whole number. Is everybody okay with perfect squares? Okay. Yes, we're getting ready to start dealing with some non-perfect squares. That means the radicand, or the number under the radical sign, is not going to be a perfect square. And so if I try to do it in my calculator, I'm going to get a decimal. And we're not going to do decimals anymore. Okay? So if you get a decimal, that is your key, that is not a perfect square, and we're going to have to simplify it differently. Ready? So what it says is we're going to find the largest perfect square that the radicand is divisible by. So that divides into the radicand. That's the number under the radical sign. And we're going to break that down using this number. So I'm going to put the list up on the board so we have it to look at. Okay, so 1, 4, 9, 16, 25. This is the same list you have on your paper. Okay, we stopped at 15. And then what we're going to do is we're going to take the square root of the perfect square. I'm just reading the words. I'll show you what it is in just a second. That comes out of the radical sign. So that comes in front of the radical sign. And then the leftover stuff stays under the radical sign. Okay? So we're going to start with 32. What I want you to do first is in your calculator, put in the square root of 32. I want to show you why this is the way it is. What do you get? You get a whole number or a decimal? You get a decimal. Okay. So that tells me that 32 is not a perfect square. So we are going to have to simplify this using some of my perfect squares. Now here's the key. Sometimes these numbers have more than one perfect square that divides into it evenly. We need to make sure we find the largest perfect square. So here's the key to do this, and you need to listen and pay attention. I'm telling you how to keep from making mistakes here. I want to look at my list, and again, I will give this list to you. I want to know what number is closest to 32 without going over. On my list, what number is closest to 32 without going over? 25. So I'm going to start here. In your calculator, do 32 divided by 25 and tell me if you get a whole number or a decimal. You get a decimal, right? So that means 25 does not divide into 32. Does everybody understand that? Okay. Then we're going to go backwards. We're going to work our way up the list. Now I want you to do 32 divided by 16. Is that a whole number or a decimal? Whole number. Okay, so that means that my perfect square 16 divides into 32. Right, Derek? How do you know? You're not even looking at me. So this is what we're going to do. We're going to split this apart. And what I mean by that is we're going to do my perfect square, the square root of 16, times, what did you tell me it divides into? 2, right? Because 16 times 2 gives me 32. You have to be able to do this because when we simplify in the rest of this chapter, we are not going to get decimal answers. We are going to leave them in what we call exact form or simplest radical form. So far, so good. If you notice, I always put my perfect square first. Right? What is the square root of 16? 4. So you're going to change that square root of 16 to just 4. So I'm going to just yes. Let me double check. No dates on that. Okay. Okay. You can, but you don't need to because it's a perfect square. Okay, so what is the square root of 16? 4. So what we're going to do is we're going to turn that square root of 16 into just 4. Do you notice I don't have a radical symbol above that 4 anymore? Okay, because I've simplified it. And then my leftover part, what is still under the radical symbol that is not a perfect square? 2. That is going to stay under the radical. And that is what we call simplest radical form, or exact answers only. Right, and the reason we say exact is because it's not a decimal that I have rounded. Does that make a little bit of sense? Yes? All right, let's try the next one. 180 is under my square root. It's my radicand. So check first we can look at our list. Is 180 on my list? No, so it is not a perfect square. If you wanted to check, you could do it in your calculator. You would get a decimal, not a whole number. So I want to go, what number is closest to 180 without going over? 169, right? So we're going to use our calculator a lot. I'm going to divide by each one of these numbers until I find one that divides into 180 evenly. So start with 169. That's the closest to 180 without going over. Does that give me a whole number or decimal? 180 divided by 169. Whole number or decimal? Decimal. Okay, so then we're going to go backwards. Then you try it again. 180 divided by 144. Whole number or decimal? Decimal, okay? Then try the next number. You're going to be doing a lot of pushing in the calculator. That's why we have these, to use them. 180 divided by 121. Whole number or decimal? Decimal, okay? Try 100. 180 divided by 100. Whole number or decimal? Decimal, okay? Try 81. Sometimes you got to do a lot of trying until you find one that works. Decimal, okay? Try 64. All right, 49. 36. That's a whole number, right? Okay, so we're going to break it down into, we're going to put that 36 first. What'd you say, 5? Okay. Is everybody okay with where the 36 and the 5 come from? Again, 36 is my perfect square. Okay, if you're not sure what the square root is, count how many, 1, 2, 3, 4, 5. It's the 6th number down, so 6 is going to be the square root of 36. So that square root of 36 turns into what number? Okay, no radical symbol, just 6. And then my leftover is the square root of 5. Do you guys kind of remember doing this in algebra? Okay. I want you to try 7 and 8. Hold off on 9 because I want to do 9 with you, but go ahead and try 7 and 8. Find the number closest to it on our perfect square list. Divide backwards until you find one that goes in evenly. Then you can split it apart. And remember, it's always the perfect square first. Then what you multiply that by. That way I don't get my numbers confused where they belong. Then go ahead and try 7 and 8. I'm going to do 9 with you because it's slightly different. 7 and 8. All right, 24. Is 24 on my perfect square list? Is 24 here? No. Okay, so that means 24 is not a perfect square. I'm going to start with the number closest to it without going over. Does 16 divide into 24 evenly? No. Does 9 divide into 24 evenly? Does 4 divide into 24 evenly? Okay. So we're going to split this apart. Again, that perfect square goes first. So the square root of 4 times what gives me 24? 4 times. Thank you. Okay, then we're going to simplify the perfect square. What is the square root of 4? Okay. My leftover, the non-perfect square, stays under the radical. So we get 2 square roots of 6. So where's that going? Now, with 8, this one is a trick. Not really, but I've seen 2 different answers. Some of you have it completely simplified. Some of you have not simplified it all the way. Remember what I said. We have to make sure we get the largest perfect square that divides into 72. That's why we start with the biggest number we can and we work backwards. If you start at the top, you're going to find a perfect square, but not the largest perfect square. Let me tell you what I'm talking about. What's the number closest to 72 without going over? Okay. Does 64 go into 72 evenly? All right. Does 49 go into 72 evenly? Does 36 go into 72 evenly? How many times? 2. So we're going to split that up into the square root of 36 times the square root of 2. And what is the square root of 36? Okay. This is the most simplified answer. Let me show you what some people do. They take 9 times 8. Okay. 9's a perfect square, right? And 9 times 8 is 72. And they simplify it. Square root of 9 turns to 3. This is not completely simplified because which perfect square still divides into 8? Which one of these numbers divides into 8? 4. So that can be broken down again. That's why we always start with the number closest and work our way backwards to ensure that we get the largest perfect square. Now, if you gave me this as an answer, I would not count it completely wrong, but I would take a couple of points off because it's not completely simplified. Does that make sense? I'll show you how to finish simplifying this after we talk about 9. Is everybody ready? All right, let's take a look at 9. That 3 in front of my radical is being what? Added, subtracted, multiplied, or divided? Multiplied. Okay, so we're going to keep that 3. I'm going to go ahead and put a dot so I know that it's multiplied. Is 98 on my perfect square list? Okay. What is closest to 98 without going over? 81. Does 81 divide into 98 evenly? Okay. Does 64 divide into 98 evenly?
No.
49?
Yes.
How many times? 2. So we're going to split this up into the square root of 49 times the square root of 2. Is everybody okay with where 49 and 2 came from? All right, I'm going to keep that 3 for now. And I need to simplify. What is the square root of 49? Okay, so that's going to turn to just 7. And then that square root of 2 is my leftover, so it stays under the radical. What do you think I need to do with that 3 and that 7 now? Multiply them. 3 times 7 is 21. Okay. Is everybody okay with that? So going back to this, okay, this is not completely simplified. You need to get in the habit of making sure that the number under your radical sign, that's your radicand, does not have a perfect square that divides into it. If I ended up with something like this, what I would have to do is keep that 3. I know that 4 goes into 8, so I would split that up into 4 times what? 4 times what is 8? 2. Okay. I would keep the 3. What is the square root of 4? 2. Okay. And then the 2 stays under the radical. And then we would multiply. 3 times 2 is 6. So didn't I end up with the same result for 8 after I simplified completely? Okay. So just be careful. Go ahead and try 10, and then we have to flip over and get the back side. We're looking for what perfect square goes into 300. Okay, our numbers don't go past 225, but 200 don't divide into 300 anyways. Keep in mind, we want the largest perfect square. If I start with 225, because that's the biggest one on my list, even though we could go to the next one, which would be 256, I believe. and then 289, but neither one of those go in. 225 does not go in. Does 196 go into 300? What about 169? What about 144? 121? What about 100? Yeah. If I have 200, 300, 400, 500, guess what goes into all of them? 100. So we're going to keep that 3. We're going to split it up into the square root of 100 times what gives me 300. Okay. Keeping the 3 out front, what is the square root of 100? 10. And again, that radical leftover stays. And then we multiply. 3 times 10 gives me 30. So the most simplified answer would be 30 square roots of 3. Kind of okay. All right, flip it over. Now we're going to talk about multiplying radicals. What does it say for step 1? Multiply the what? Coefficients. Does everybody know what a coefficient is? That's the number in front of the radical. Just like a coefficient of a variable is the number in front of a variable. My first radical for number 1 is the square root of 8. What is the coefficient of it? What number's in front of it if there's nothing there? A 1. Okay. So first step is to multiply the coefficients. So what we're going to do is there is a 1 out here. What's in front of the square root of 2? Negative 3, right? So what is 1 times negative 3? Negative 3. So that we're going to put that in the front. Outside times outside. The numbers in front of the radicals get multiplied. Then step 2 says to multiply the radicands using the product rule. What that product rule says is if I have the square root of A times the square root of B, then I can do the square root of A times B. Okay, all under one radical. So then what numbers are under my radicals here? 8 and 2. Okay, so I'm going to keep the square root. What is 8 times 2? 16. Once I do the multiplying, then I have to simplify if I can. Okay, so let's look at the square root. Is 16 a perfect square? Yes, it is. So we can simplify that. We're going to keep that negative 3. And what is the square root of 16? 4. So that turns to just 4. Right? Okay. And then we multiply. What is negative 3 times 4? Negative 12. Okay. So try to multiply the coefficients, the numbers that are in front of the radicals. If there is nothing there, it is understood that there is a 1. Okay, if there is a negative, that means it is a negative 1. So multiply the numbers in front of your radicals first. Then multiply the numbers under the radical sign. Then we're going to try to see if we can simplify. What numbers are out front? A positive 1 and a negative 1. Okay, positive 1 and negative 1. If I multiply those, that gives me negative 1, right? Sorry. And then we're going to multiply the numbers under the radical sign. The square root of 3 times the square root of 2 is the square root of 6. Is 6 a perfect square? So if it's not, then my next question is, do any of my perfect squares divide into 6 so that I can simplify? What's the only perfect square that's not bigger than 6? 4, and 4 doesn't divide into 6 evenly, right? Which means I cannot simplify that. So you can leave your answer like this. Or would it be okay if I just did this? Does that mean the same thing? Yeah. So either one of those. You can write the 1 there if that makes you feel better. Or you do not have to. You have to have the negative sign. You do not have to have the 1. Make a little bit of sense? All right. Start the multiplying process for 3. Outside numbers get multiplied and stay outside. Inside numbers get multiplied and stay inside. Then we're going to see if we can simplify further. Outside times outside, inside times inside. Then we're going to try to simplify. Outside times outside, inside times inside. What are the two numbers outside? 5 and, come on, what's it outside of the 12? 5 and negative 7. If I multiply those two, I get negative 35. Okay, then we're going to multiply the numbers inside. What's 10 times 12? 120. Is 120 on my perfect square list? No. So what I need to do now is try to find a perfect square that divides into 120 evenly. I start at 100, correct? Because that's the one closest to it. And I'm going to work my way backwards until I find one of those numbers that divides into 120. If none of them do, then I can't simplify. But you should be able to find one that divides in. Anybody find it yet? Keeping that negative 35. Has anybody found a perfect square that goes into 120? 4 times how much? 30. Okay, 4 is the only perfect square that goes into 120. So I'm going to keep that negative 35. What does the square root of 4 turn into? What's the square root of 4? Okay. And then that square root of 30 is going to stay. And then what do I do with that negative 35 and that 2? Multiply. What's negative 35 times 2? Negative 70 times the square root of 30. Okay. Last one, number 4. Go ahead. Outside times outside. Inside times inside. And then simplify. Just because I'm giving you the phones doesn't mean we're done with our notes. I just don't want to run out of time. We should all be working on that last example. Outside times outside. Inside times inside. We're going to find the square goes into it. I'll go over it as soon as I get done passing. Okay. Outside times outside, inside times inside. What do I get when I do negative 4 times 2? Negative 8. And then 14 times 8 is 112. Okay. What perfect square goes into 112? 16, how many times? Okay. Keeping the negative 8. What is the square root of 16? 4. And negative 8 times 4 is negative 32, square roots of 7.